Right. Good afternoon, class. Last time I kind of introduced you about how to solve a system of equation using inverse. I did that, didn't I? Right. Now let me recap. Let's go back to the real number for a moment. If I want to solve 2x equal 3, well, naturally you divide it both side by 2, right? But let's just say instead of divided both side by 2, I am multiplying both side by the inverse of 2. Say 2 to the negative 1, like that. 2 to the negative 1, which is the same thing as 1/2. Right? 1/2 times 2 is 1. So that part right there, 2 to the negative 1 times 2 equal 1. So that's just x, right? So 1 times x equal 2 to the negative 1 times 3. Well, 1 times x is x, right? 2 to the negative 1, that's 1/2 times 3. So your answer is 3/2. I know it's long, but for the sake of our inverses of matrix today, that's why I show you that, right? So in general, for a real number, if you want to solve a linear equation ax equal b, then all I have to do is multiply both sides by little a inverse, right? And it'll cancel. A inverse and a will cancel and leave me just x. So now I got x equal a inverse times b. Notice that I know in real number, it doesn't matter where you put your a inverse, but notice that I put the a inverse in the same order as in left-hand side and right-hand side, right? If I put a inverse on the left, here on the left-hand side, I do the same thing for the right-hand side. It is on the left. And you should do that for the matrix, yes. Why can we what? Well, you can if with the real number, but for matrix, you not be able to solve in the normal way, right? So that's why I introduce you just this different approach. Does that make sense? Now, for square matrix, how do I solve big A times X equal big B? A and B no longer a number, so you cannot divide both side by A, right? Because you don't have division for matrix. You have multiplication matrix though, right? So using the same approach, what I can do, I'm not gonna box it yet. So let me do like this. What I can do is multiply both sides by A inverse, like I did, right? What A inverse times A equal? In the world of matrices, A inverse, in real number word, little a inverse times little a is 1, right? In matrix word, what do we call it? The 1 in matrix is the identity, right? The identity. So that's your I, right? Times x equal A inverse times B. Well, I is kind of like 1, right? 1 times x is 1, I times x is x. And that's how you solve for x, right? Using inverse matrix. And please do not exchange the position of A inverse and B, okay? The location of A inverse and B. From last lecture, if I let A be a square matrix of size n by n, a square matrix A inverse of the size n by n such that A times A inverse is the same thing as A inverse times A equal I. It is called the inverse of A. Show that the given matrix is the inverse of negative 1, 2, 4, 2. How do I do this? Well, if I multiply them together and they come out to be I, then they are inverse of one another, right? using the formula. Right. So here's your A. That's your A. And that's your A inverse. If you multiply them and they equal to I, then you can conclude that they are inverse of one another. So let's do that. Negative 1/5, 1/5, 2/5, 1/10 times negative 1, 2, 4, 2. Everybody remember how to multiply two matrices? Row times columns. All right. The dot product. First row times first column. Negative 1/5 times negative 1 is positive 1/5. Use your calculator for the arithmetic. Maybe I'll write out here. Plus 1/5 times 4. I'll write it down. First row, second column. Negative 1/5 times 2 plus 1/5 times 2. No, why it doesn't work. Second row, first column. Two-fifths times negative 1 plus 1/10 times 4. Second row, second column. 2/5 times 2 plus 1/10 times 2. Simplify. One-fifth plus 4/5 is 5/5, which is 1, right? And the next one is 0. Bottom left, 0. Bottom right, 1. So yes. So that's how you prove if given two matrices, it's how you prove if they are inverse of one another. Why is only square matrix invertible? Now only square matrix invertible, and not all square matrix has inverse. We're gonna come back to this question later. But let me show you. Oh no. Bless you. We'll come back to the question later. But first, I want you to find the inverse of the given matrix. Well, we're going to use a formula that we know so far. Remember, there's many ways to do this, but so far you only know one way, which is, you know, the A times A inverse equal I, right? Or A inverse times A equal I. Use one of them. Doesn't matter which one. Do the same thing to me, right? Let's use the first one. So if I call this A, if I call that my matrix A, I want to find A inverse, right? So A times A inverse equal I. A is negative 1/2, 3, negative 3, 2/2, 2 times A inverse. I don't know what A inverse is. I'm going to call them A, B, C, D. Equal I. You know what I? That's identity matrix. 1, 0, 0, 1. We did this before. I hope nobody divides both sides by that matrix. Yes.
Isn't the first number just -1?
-2/3. Oh, -1. So thank you. Thank you very much. Thank you. I really thank you. The way I want to do all that competition and it's wrong. We did this before. Do you guys remember from last time? Given that, can you convert it into a system of equation using the matrix multiplication? Okay. So first, let's do the left-hand side first. Let's do that one. First row times first column. We need to combine them into one matrix, right? Why do we do that? Because if the left-hand side equals to right-hand side, we can let each of the entry equals to each other, right? And then we solve. So -1 times A plus 3 times C. First row, second column. -1 times B plus 3 times D. Second row, first column, -2/3 times A plus 2 times C, -2/3 times B plus 2 times D. Move it up a little bit. You simplify that, -A plus 3C, right? -A plus 3C. The right, top right will be -B plus 3D. Bottom left, -2/3 A plus 2C. Bottom right, -2/3 B plus 2D. And is equal to the identity matrix on the right, 1, 0, 0, 1. Two by two equal 2 by 2. So each of the entry equals each other. So I have a bunch of equation here. I have -A plus 3C equal 1. I have negative b plus 3d equals 0, negative 2/3 a plus 2c equal 0, negative 2/3 b plus 2d equal 1. I'm going to call equation 1, equation 2, equation 3, equation 4. Equation 1 and equation 3 have the same variables, right? So we're going to combine them together. I want to eliminate something. Can I multiply the first one by negative 2/3? Is that okay? So negative 2/3 times row 1 plus equation 3 negative 2/3, right? Negative 2/3. And then you add to the third one, 0, right? Negative times negative is positive, so 0. I'm gonna write down for you 2/3 a minus 2c equal negative 2/3. That's equation 1. Equation 3, I'm just rewriting this, negative 2/3 a plus 2c equals 0. Add them together. What happened to the left-hand side? What's the left-hand side equal?
0.
0. Yeah, thank you, Mike. 0. And the right-hand side is negative 2/3. Is this true or false? So what do
True.
you do?
No, that's false. One thing.
You say no solution, right? You're done. Nothing you can do next. So if you cannot find solution, you say no solution.
How did you get from negative? How did you go from negative 2/3 to 2/3?
What I did was I take negative 2/3 times equation 1. Does that make sense, Mike?
Kind of. I'm still a little bit confused.
Negative, you didn't. Negative 2/3 times equation 1. Can you tell me? Can you tell me what's equation 1 on the?
Is it the negative a plus 3c equals 1?
Yes, that's equation 1. You're gonna take negative 2/3 times that equation. So let's take negative 2/3 times each of the term. So negative 2/3 times negative a is positive 2/3 a. Yeah.
Oh, okay.
Negative 2/3 times 3c. The 3 and the 3 cancel. So I have negative 2c. Yeah. And then negative 2/3 times 1 is negative 2/3. It's false. So
Okay.
yeah.
I got it.
No problem. So no solution means what? No inverse, right? There's no inverse for that given matrix. That your final solution. Because you cannot move on. You just gotta stop there. All that work. So far, so good. So far, I only introduced you the definition of A inverse. Okay. Now, let's find A inverse a different way for 2x2 matrix. 2x2 matrix is special. There's a formula for it. It's kind of like quadratic formula. You know, it's quadratic equation is special because it has a formula. It's called quadratic formula, right? If you don't know how to factor it, you can always use quadratic formula. Same thing with the inverse of the 2 by 2. Right? There's a formula. So you can plug it in and just calculate it out. Now 3 by 3 is not the case. You don't have formula for it. You have to go the long way. If given A is A, B, C, D, then A inverse is 1 over A times D minus BC. This thing is called the determinant. So 1 over the determinant D, they a lot of time they denote as capital D times the new matrix, which is for A and D, you swap their place. And for B, C, you keep them the same, but you add you make it opposite to the original entry. Okay. Oh no, that's me. It's only this room. Maybe I should request different room next semester. The other 2 rooms fine. I never have any problem. No problem, Mike. I muted you. No, yeah, we got old school again. All right. Sorry about that. People from home, can you guys see my screen?
I can see it.
Oh, okay. So yes, right? Is it yes?
Yes.
Thanks, Mike. All right. All right. So let's use the formula to find the inverse of A using the formula. Right. So A inverse equal 1 over AD minus BC. A is 1, D is 0, minus BC, B is -3, and C is 5. Now let me have an eye. Hang on. Let me rewrite this in black. 1, 0, -3, 5. So that you know which one is come from the entry, which one come from the formula. And times the matrix now is DA, right? So 0, 1, swap D and A and D. And then for B and C, you make it opposite. So instead of positive, -3, it's going to be +3 here. +5 become -5. The denominator is 15, yeah? 1 over 15. 0, 3, -5, 1. We learn how to multiply a scalar to the matrix, right? You just multiply with each entry. 1/5 times 0 is 0. 115 times 0 is 0. 115 times 3 is 1/5. Please simplify it as well. 115 times -5 is -1/3. And the last one, -1 over 15. And that is your A inverse.
Would it be negative 1/15 or 1/15?
Negative 1/15. Oh, 1/15. Sorry. Sorry. Thank you, Mike. Yeah. Now, let me go back to the two questions that I said I'm going back. Where are they? Why is only square matrix invertible? Because from the problem we just saw, what do you need in order to get them, in order the matrix to have the inverse? You need what? You need the determinant to be valid, right? Imagine the sorry. Imagine the determinant is 0. AD minus BC is 0. 1 divided by 0 is undefined, right? So we cannot have that. So therefore, only square matrix might have an inverse because you'll be able to find what the determinant, right? You cannot find the determinant with the rectangular matrix. How are you gonna do it, right? There's no AD, BC, right? They're not symmetric, right? So that's the reason why. Now, furthermore, not every square matrix has an inverse. We showed that, right? This one right here, the one that we just did, it's a square matrix, but it has no inverse, right? Let me tell you the reason why it has no inverse. You don't have to copy this down. Why don't you guys try to calculate the determinant that for me? Just the determinant. AD minus BC. Come on. What do you have? Don't look at me. She tries to calculate that. The determinant is AD minus BC. Just A, the first one, B, 3, C is negative 2/3, D is 2. Negative 1/2 times D is 2 minus 3 times negative 2/3. What is it equal to? Negative 1/2 times 2 is negative 1. The second one, negative become positive. 3 cancel. So did I do something wrong? Oh, negative 1. I keep saying negative 1/2. I'm so sorry. It's negative 1. So positive 2, negative 2, 0. That's why there's no inverse. Right? The determinant is 0 because you have 1/0. No inverse. Your extra credit today question?
I'm like, oh yeah, I remember.
Mike, can you mute yourself?
Was I not already muted?
Sorry, maybe it was somebody else. But somebody else, can you guys mute yourself? Nothing like that on the exam. Because you'll be in big trouble. Man. Why is it only square matrix invertible? That's your extra credit question. So that's 2 by 2. There's a formula, so it's nice, right? We have a formula to work for. Now, what if we don't want to use a formula? What if we want to use the general way? In general, here's like this. In general, you have something like this. There's an algorithm to solve for inverse for any square dimensional matrix at all. Right? You're gonna write the matrix as A and then given I. Right? That little line is given I. A is your given matrix. I is your identity. Apply row operation, Gaussian elimination again to get a converted as I. The right side matrix is inverse A, aka A inverse. What do I mean by that? So let me explain it to you. What do I mean by this? What I'm going to do, first, I'm going to write my matrix as A given I. And slowly, using Gauss-Jordan, which is a long process you did on your quiz, using Gauss-Jordan, we're going to convert. From this, we're going to convert. On the left-hand side, it's no longer A, it's gonna transform into the identity matrix, and on the right-hand side, gonna transform into A inverse. That's what the whole, that's what the whole 3 bullet points said. So you start out with A, like a pair matrices side by side, right? The only thing separate them is a line, the vertical line. And then using Gauss-Jordan elimination, we're gonna transform the A into the identity matrix. Then the other one will be A inverse. Let's do that with this one. Let's do that with this one. 1, -350. So that's your matrix A, right? And then on the right, on the other side, the parallel matrix will be the identity, which is 0, 1. Well, I'm sorry, 1, 0, 0, 1. Let's use Gauss-Jordan elimination. I need to make, remember, I need to make that, this matrix right here turn into an I. Right? That's my goal. That's my goal, right? So first I have a 1, which is good, right? Which is good. Next, I will need to turn the 5 into a what? 0, right? Just like we did with Gaussian elimination. You need to make that 1 equal 0. So the step will be -5 R1 add R2. Give me new R2. Right. 1 -3. Just 1 0. So the first row is the same, you don't change it, so I'm rewriting it. The second row is -5 times R1 is -5 plus 5 0. -5 times -3 is 15. 15 plus 0 is 15. Negative 5 times 1. Basically, what you do is you multiply the whole row here by negative 5. Negative 5 plus 0 is negative 5. Negative 5 times 0 is 0, plus 1 is 1.
Where'd you get the negative 5 from when multiplying again for the last one?
Negative 5 times 1 plus 0. We multiply the first row by negative 5.
Oh, and then you added the 0 because it's the one on the right.
And then I add it to the second row. You see the instruction here? I circle in the ellipse. That's the instruction. I'm taking negative 5 times row 1 and then add to row 2.
Got it.
Now we need to make the 15 into 1, but that's later. Okay, we'll worry about that last, right? The next step is you make this one 0. We'll worry about that last. Any suggestion? What should I take? What times what? Add to what? I need to make the negative 3 into a negative 15, right? So I'm going to multiply the first row by 5. And then I'm going to add to row 2, right? So row 2, R2 plus 5 R1, give me new R1. The one you want to change is on R1. So row 2 stay the same. Rewrite it before you forgot. 0, 15, negative 5, 1. 0 plus 5, 5. 0. Negative 5 and 5, 0. And then 1 and 5 is 6. Something wrong here? I think I did something wrong. Did I copy it down wrong or something? One negative 3, 5, 0. 1 negative 3, 5, 0. Let me double check my math. Negative 5 R1 plus R2, so 0. 15 plus 15, negative 5, 0, 1. Okay, I'm all right. And then the second part, I need to get rid of negative 3. So negative, so take and multiply by 5. 0, 5, 0, 0. Did I make a mistake somewhere? I think I make a mistake somewhere. I'm not. I make a mistake somewhere.
You mean when copying down, or?
Did I make a mistake somewhere? Let me double check this one here. Let me double check if I make a mistake. AD time minus BC. A A is 1, D is 0, minus B is -3 times C is 5. So positive 15, that's right, 1 over 15. Swap A and D, so swap 1 and 0, positive 3 minus 5, 0, 1/5, -1/3, 115. No, I'm not wrong. The only thing I did wrong was something wrong with this one right here in blue. That's the only one that got wrong. Did I make a mistake on that one? Let me double check. Yes, I did. It should be a 1 here. Didn't I? -5 R1 plus R2. No, it's not. Darn it. 1 and 0. 0. Let me double check. 15. So 15. -5 is -5. And 0, 1. Times 5. Times 5. R2 is 0 plus 5. 15, 0, -5. Positive 5 is 0. 1. Oh, that should be a 1. 1 plus, oh no, 1 plus 5 is 6. Darn it. 1 plus 5 is 6. Something. Oh, it's 1. Sorry. Yeah, 5 times 0 is 0. Plus 1 is 1. That's what my mistake. Okay, found it. Sorry about that. Remember, our goal is to change the left equation into I, right? I need that guy to be I. So remember, need to be I, right? So 1/5 R1, give me new R1, and 1 over 15 R2, give me new R2. 1, 0, 0, 1/5, 0, 1. -5 divided by 15 is -1/3. 1 over 15. That's right, there's your A inverse. And it matched with our problem, right? So that's a long way. That's what I meant by long way. The lucky thing is that for 2 by 2, you have formula. You don't have to do this unless you are asked to. You can use a formula like this. Now, the reason I'm showing you this because as soon as it comes to 3 by 3, 4 by 4, there's no formula. You have to do the long way like this, which we're going to do in next time, right? Today, I want you to do this one, our last one, and then we'll call that a day. I want you to find the inverse of this one.
Sorry, I was still copying. I'm still copying the answer. Sorry. I got it. Thank you.
Using this, I want you to practice this. Do this, right? This is the other one easy. That'll be our last problem for today. That's your beginning one, right? And you convert it into I and then A inverse at the end. That's your goal. Don't think too much at the time. One step at a time. Your goal is to change the 3 to a 0. That's your goal for now. Forget about everything else. What should I multiply which? Add to which? Negative 3 R1, that's what I see people write. Add to R2, give me new R2. Rewrite the first one for both sides. And please put the line in between, right? It's not, don't do this. That means two separate matrix. We're not doing two separate ones. We're doing one of them, right? We just have two sides. Right? 0 here, negative 3 times 2, negative 6 plus 4 is negative 2. Negative 3 times 1 is negative 3 plus 0 is negative 3. 0, 1. So far, so good. That's what I see people do. My next step is to make the 2 0. Don't worry about the diagonal to be 1 yet. That will be the last step as always. So, oh, that's not too bad, right? All I do is to take R2, add to R1. Give me new R1. So rewrite R2. The one doesn't change, is the R2. So rewrite that. Let's see, R2 plus R1. So 0 plus 1. 1. Negative 2 plus positive 2, 0. Negative 3 plus 1, negative 2. 1 plus 0 is 1. Almost there. Negative 1/2 R2. Give me new R2, right? I need to change that negative 2 into 1. The first row stay the same. The second row change. Negative 1/2 times 0, 0. Negative 1/2 times negative 2, 1. Negative 1/2 times negative 3, 3/2. Negative 1/2 times 1 is negative 1/2. There's your A inverse. Let me show you how to use this in calculator. Now we're done. Just check. Wait for you to copy that down. Second matrix, edit, right? Matrix A is a 2 by 2. So you need to change the dimension. 1, 2, 3, 4. It's pretty simple. So 1, 2, 3, 4 ahead. Quit, go back to second matrix. Select matrix A, enter. Sorry about that. And the A inverse, right there. I know it's kind of dark, sorry about that. It's right above the square root, right below math. There you go. We have the same answer, right? Negative 2, 1, 1/2, 3/2, negative 1/2. All right, if nothing else, have a good one, and I'll see you again on Wednesday. We have a quiz on Friday, though. You too.